Hey folks, before the video begin, you can hear it. I'm not a native speaking English guy and my English is very bad. So don't get 100% seriously about the words that I use. It's because of my missing knowledge of English, sorry. But it's not a problem because it's so easy. You can watch and understand, and with my little English I hope I can help. So let's begin.
Speiste Gereiste reisen selten bis Elba.
Na, machtet euch halt selber.
It's a very easy circuit. I show you with the PC the schematic. But I have something to explain. I try a lot and do something and blah blah blah. And for this I changed the capacitor too. Now I have to change it back. And I will show you the whole experiment, what I did in German, in English. I try. If it not works, I cut. And someone else have to do it because it's so easy. We got two capacitors. With 5600 picofarad. In another experiment I tried 1 microfarad. And it's the size of the capacitor is only important, in my opinion, now if you want to measure input and output. So if you go in with the same capacitor with, we say, 2 volts, and after the process we got 2.1 volt, whereas the 0.1 volt coming, and 0.1 volt with the same capacity is more energy. I hope you understand. You got 2 capacitors, you know, and I use a switch to turn on, also off, now it's off, on, and so I can load the first capacitor without the coil. If you don't do this, the measure, sorry I can't speak this word, yeah, is wrong. You need to have only load the first capacitor. You can do it so, without the circuit, and then connect it to the coil, not first. If you do it first, it's wrong. You got the wrong results, you know. And yeah, you need a transformer with secondary coil and primary coil and secondary coil. I use in this 2 diodes. On the schematic you see one is free. Now I make it so I can switch with the cable. You will see it in the video. And that's it. On the schematic you can see where is the cable from the first coil to the second coil, and that's going to the diode. The diode, if you have to put it on this diode, is anti-parallel. I hope you see it. And the polarity of the input, you have to switch maybe. If you switch the polarity on the input, maybe you have to switch here, but you have to watch about the coils. If you switch the polarity, you have maybe to switch the second coil. Not no winding, that's clear, but switching the poles. I hope you understand. I think it's clear. Now I'm switching the capacitor to the same. I show it to you. Not that you say, oh no, it's not the same. It's not 100% the same. 0, this is bad. Okay, for you guys, I switched to the 1 microfarad on 2 sides. On this side it's already done, and I switched this to show it. I got the same capacitor in and out, and now I show you the first with easy measural. I can't speak this word, dude. Fuck it. Messuar? Messuar? I call it messuar, sorry. I'm bad. Nee, mad? Bad? Nee, mad. Not bad. I'm a good guy, boys. So, we look at the simple thinking. And for this we use I show you 18650 lithium-ion battery. And this battery, I show you, we have nearly 4 volts or something. I think 4. So I got this connect, and we got 4.2. Now it's you see 4 parallel. This Akku have enough power to not break down if I charge this little capacitor. I hope you know. So I disconnect. So I disconnect the voltmeter now, and we will measure the second capacitor. Give me a second. So now the voltmeter is on the second capacitor. You see, it's auto, nearly 0 volt. You see millivolt in the corner. If I got 1 volt or more, if it changed from millivolt to volt automatically. Okay, we got 4 volts in this. I call it the Wochenschrauber in this Akku, and I got positive and negative from this Akku to the first capacitor. And if I connect, I can show you that the switch is not touched. Nothing happened. Only cap 1 is lowered with 4 volts. 4.2. Nee, 4.02. So now we have to disconnect. Moment. I show you that I don't cheat. Maybe you think I'm cheating. And we're going to this capacitor. 4.2. Okay, 4.2. And we go to the coil. Nothing. Okay, I'm not cheating. So now we measure the output. Now we got something. I have to short it. Sorry, short. Nothing. Nothing. Now we disconnect the capacitor, the Akku, and I have to be quick. because the size of the capacitor they go very quickly down, slow, the voltage, if I do something or not. So you have to be quick. And for this we look at the voltmeter. I put it together. You can see that when I press the button, it do something. Now I disconnect and do it. Watch the voltmeter. Have not work. Huh? Sorry guys. I think maybe I have connection trouble. I have to short it again to see. We have, if I explain more, I have to short it many times. Try next. Doesn't work. Moment please. Now after destroyed my first row, I have to build it new. Okay, let's begin new. We got our coil, no transformer, only coil, a diode, two capacitors, two caps, and a switch. I show you 4 volts something. I charge the capacitor. We have 50 millivolt. I discharge this completely. And now disconnect input and power. You see, it's nearly 4 volts. On the first setup I got, you can see it in the videos, I got over 4 volts. But that doesn't matter. You can try it at home to get more at you get in. So, but yeah. Now, I forgot. Now I have to show him. We look at the oscilloscope with this in this condi after we do this and without. Now I got the oscilloscope on the coil and we look at the pulse without the second capacitor, so we know what is going on. And so for this I go to single trigger, and if I do something it will change. It changed because I touch it. Okay, so I have to charge the capacitor, start it again. He triggered something. It's too good, this OSC. Okay, I try again. I hope you see. If I disconnect, you see he triggers. Why he do this? Okay, I think I got too close with the probe to the input, so it triggered the input signal. Now we try it again. Capacitor's load, it's still running. Pop. Triggered. And stop. So now we can see the pulse without anything. The capacitor is not connected. So we got, well, it's not, oh, we only get 3.6 like this. But it doesn't matter. So now we can say, let's say 1 volt pro block. Okay, 1, 2, 3, 4. Nearly the 4 volt we put in. It's not magic. We remember 4 in the height and 1, 2, let's say 2, you know. So do it again, but this time with the capacitor 2 on it. 1. Charge the capacitor. Hope please don't recognize it. Don't. Zack, push it. And now we got the... it's even better before. But you see, it's even more, dude. Okay, but I have to tell, it's not really the same. If I need 1 millisecond longer to press the button, it will not display exact the same. But if I get nearly the same voltage back in the same capacity, and the signal is same, nearly the same, how it comes from. Do you understand? We have 1, 2, 3, 4. Little bit more. But let us call this, not this peak. Forget it. So, and now 1, 2, 3. Do you understand? It's maybe I show it again so we understand it. This pulse is equivalent of the voltage we see, and the voltage we see and the pulse we see is the power that is in this second capacitor, and it's nearly the capacity. The energy from in and out. It's nearly the same, but we do work. So let me show it again. Now we disconnect. Now he triggers this. Even the disconnect triggers the oscilloscope. It's very sensitive. Now next time it's triggered. Maybe the cable's wrong. I don't know. Disconnect and fire. Now we have the pulse. Oh, now it's better. Now you see it. 1, 2, 3. Okay, now this is better. This is better. The first time was not good. We got the samely, nearly the same result. Maybe the Conti was charged. We got over 4 volt, nearly 5 volt. It cannot be happen. Sorry, I have to discharge the first one. No. Oh, I don't know. We have to do it again. Maybe it's a fail from me. So disconnect. Zack. So now we got the right peak. And we got more when we put in. Why this happened? But I hope you get the point. If you measure it exactly like my other videos, you cannot see clearly. I cannot show it so clearly because I think, I don't know really, but I think the coil capacity maybe is not right also, or something. But we try it again. I go to 2 volts per. Now it's at 10 volt. Now the amplitude. Maybe it's making. Wait a minute. We have 10 volts now. Okay, let's try it again. On fire. Zack. Okay, now we have for positive, for negative, nearly. It's not the, you see it, no? And 1, 2, 3, 4. 1, 2, 1, 2, but on the red side is not so important. But you will see, now we try it again. I think now it will work. 1. I don't charge the capacitor. Charge the capacitor. And fire up. 1, 2, 3, 3.5. But it's depend how I have to go faster. Wait a second. Sorry, guys. It's better with no camera in one hand, so I can do it with 2 hands. I hope you understand. So I show you this angle. Zack. No, I don't get it too fast. But we see 1, 2, 3, nearly 4. Nearly. No? It's not perfect. I'm not fast enough to get the 4 volts. But it's nearly the same. You see it? We try it again. And after this I can show it on a level. I hope you trust me. I don't show this in this. We can try. Let me try something. I need 2 hands, boys and girls. So you can see nothing. Perfect. You see? Okay, you see. And the oscilloscope. A little bit, I hope. What's a reflection? Now, with disconnect capacitor. It's time to get it. Can I use 2 hands? So we got in the beginning nearly the same. It's the EMF peak. You see a high peak, but 1, 2, 3, 4. Yeah, no. Now you see. It's not exactly 4 volt from this. Ignore the peak. You see? From 1, 2, 3, not 4, because it need time to press, and I don't get the 4 volt. I hope you understand. If you see nearly 4 volt, I don't go in with 4 volt because I'm too slow. If I see the 3.8 or 9 or something, you already got it. So now you see it again. I go back to like this and connect the capacitor, load the first capacitor, but now we have to for safety, so we can not lie to us, to discharge the capacitor too. Start the and go. Okay, 1, 2, 3, little bit less from the input, but the camera, I put you back, and now we make the same. I discharge the second capacitor, charge the first one, press run, and I will use 2 hands, sorry. Up, oh. Go on back. No. Oh, I can't disconnect. I press it to the contact. Upwards. No, it not really worked so well. 1, 2, 3, 3 point. I don't know, but it depends how fast I am. I try it again. but discharge the capacitor. I don't get it. Maybe it's not perfect coil, but 1, 2, 3. I won't show it better, boys and girls. This is shit. But why it's not working like yesterday? I accidentally smashed this transformer, I think, you see, and now it's not working anymore. But maybe you get a point. I tried again and talk something. I can understand that this is not showing 100% it's right, but it showed the principle. I hope you understand. So my plan or idea is, after this video I go to my older videos from this transformator and re-upload the video with English talking. I know you hope my English talking very much. Can't live you can't live out without it, oder? Oh. Okay, try it again. Now I don't disconnect the input, it's not right. Okay. I nearly got it, boys and girls. You see? I have not disconnected anything. It's still connected. And look, we got the same, like the first, second, you know, in the back of the video, you saw the same result without capacitor, sorry. So now we look, we stretch it like before, 1, 2, 3, nearly 4, okay? But no, this is not perfect. Do it better, you get better results. But you can see this imagine is it is the same. For me, we can. You see, the EMK is nearly on, like the last time without it. Do you understand? As nearly 4, we do it last time, and after this I have one thing more for understanding. Please hold the line. Okay, now we disconnect the capacitor, and so I have not to discharge it. Load the first one and try to get this signal so you can, hopefully I show it already. So do it quick. Yes, worked. You have to be really fast if you want to compare, or you have to build a circuit to make it every time the same, as 100% the same, not like me. I'm a millisecond faster, slower, and the results are not so good. So now you can see this is the input. I'm 1, 2, 3, nearly 4, without the peak. On the outside we got the peak. You remember? So, and now we can compare it. I hope it's right. We can look at it in a longer time, so you can see it, not the length but the height. I hope you understand. I explain. Hold the line. So if we turn off the solo trigger and go to 1 volt and let's no, I have to okay, 50 milliseconds. Now it's run and run. I don't show you, I say click and after this I click, okay? I cannot show both. Okay, and we have to things really fast. So you see, this what you see, I hope it can stop it. No, I'm not fast enough, you see it? I stop it after I put you in our special position and now I can with the second hand stop the oscilloscope and we got the pulse, and this pulse is now like this, you see the whole time, but you see it is in the length not so much, but the height is same, no? And but it's it's 7 volt now. Oh, okay, it's more, no? Easy. Okay, doesn't matter. So now we shot it with 50 milliseconds. I run it again. I do nothing to the circuit or something, only switching the time. But you see the difference. There is no difference, but you have to understand understand the next step. So I charge the capacitor, press it, now we have time, 2 seconds, and what you see is what you already seen, but compressed. Maybe I can shot it in the right position, but I cannot look deeper because we make it so small. I hope you understand. I cannot better explain. But if we now see one line, it is not one line. It's what I showed before. Downward sinus. I don't know the right word in English. Downward sinus. And now the downward sinus is a line. I hope you got me. And now we have time, and I can show you the first signal pulse. After this, I have time to connect and do it again. We can press stop and look together at it. I hope you understand. So it runs. I have to be quick anywhere. If I'm slow, it will be better or worse in sometimes. Sorry. For this you have to make it like with a circuit. The first time we try without capacitor. Second capacitor. I load the system, disconnect, fire it up. Now it has to be quick. Connect the capacitor to discharging with a screwdriver and connect the input to charge and disconnect and fire up. But I am very slow by fire up. Oh, very bad, boys. Very bad. Very bad. But I hope you got it. Don't get this. This is it. No, I am too slow at the second pulse. But where it is, we got the input normally, and this is with our setup. But it's not right. I'm too slow, boys. I am trying try to think that in the German videos we got bigger in the German videos it was switched. This was input and this was output. I hope I can show it for you guys, but I can a little bit for demonstration. Let's by the first experiment without condensator, a capacitor. Let me 1 second to press. I disconnect the charge and let 1 second, so maybe we can it see better. It's not correct, I know, but it's for understanding. Okay, I hope on this point you have already understand it. So I charged the capacitor 1. We fired up. I don't wait very long. Now connect the second capacitor, discharge this. Load the first capacitor, load and up and press. I hope we got some. Oh, oi, 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 oi. So now you see what I mean. I hope so. I hope so, boys and girls and world. We got it, boys. It's so easy. It's too easy. Look at it. You understand it or not? This is the pulse from the downward sinus, and this is the bigger downward sinus. It's like, but I call. It's not 100% correct. I'm a little bit cheating, okay? Because my original device is destroyed. If you watch my videos, it's induction without magnets. So I destroyed it with a hammer. Okay, we look at it. It's not correct, boys, but if you remember Victor Schauberger, if this is 1 block and this is 2 blocks, you now you can nearly see that 1 explosion or ignition and or action reaction, 1 reaction, 2 reaction. 100 years, boys. Have a good day. Bye bye.